Okay, so today we move on to lesson 3.5, chapter 3, part 2, which is something called matrices I'm going to introduce to you. So pause the video, take a look at the problem of the day. You ready? Move on. The problem of the day is from lesson 8.6, the last material we covered. All right, so 3.5 is called perform basic matrix operations. Matrix, if you look down here before I start, is a little block of numbers, all right, in rows and columns. Matrices help us with a lot of things in real life. There's a lot of practical applications to them. If you remember earlier in chapter 3, way back, second quarter, first quarter, we reviewed solving systems of equations. Do you remember, like, we had substitution, elimination, graphing? Well, you could use matrices to solve them. Now, what if you had more than two unknowns? Like we had x and y as an unknown. What if you had 3 unknowns, or 10 unknowns, or 100 unknowns? Matrices helps us to solve them. And something, the more technical you get into matrices, there's actually computer programs that do it for you as well. So there's a lot of computer science involved. I learned about matrices in physics, actually. Physics uses it as well. So there's a lot of practical applications to matrices. Let's start off first and foremost. You guys can copy this down. What is a matrix? A matrix is a rectangular arrangement of numbers in rows and columns. Dimensions, m rows and n columns, m by n. I remember RC. So if you look at our little example here, we have 2 rows, 3 columns. The elements are the numbers in the matrix. So it shows you here the element in the first row and third column is 5. So this is the first row, third column on the left. And then equal matrices, if both of their dimensions are the same, and the elements in corresponding positions are equal. We'll talk a little bit more about that as we go on. All right, well, we start off today with adding and subtracting matrices. They must have the same dimension. Now, if you look here, I have what? 2 rows by 2 columns. It's a 2 by 2. I have 2 rows, 2 columns. So I am allowed to add them. When we add, we go across. Here's the top left, top left. So that would give us b plus f here. And then down here, bottom left, c plus g. Bottom right, d plus h. And don't forget your little block for matrices. So it's still a 2 rows by 2 column matrix. Rows by columns, right? But there's a new number here, 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 and here. All right, well, how does that apply to subtraction? Same idea, right? So we'll do a minus e, b minus f in the top right, and c minus g, and then d minus h. Once again, it's still a 2 by 2. We'll just get new numbers for each of those positions. All right, well, let's take a look at an example actually doing that. All right, so example 1, perform the indicated operation if possible. All right. So if I start here, I have what? The top left. I get 2 plus a negative 3, which is 2 minus 3. 2 minus 3 is negative 1. So you see how we are doing order of operation, or we're doing integer rows. We're taking the same position for each. Let's try the next one. Top right, 4 plus 2, 6. Bottom left, 0 plus 4 is 4. Bottom right, 1 plus 0 is 1. And that's it. That's how we add matrices. Now, if possible, why was this possible? Did you see I have a 2 row by 2 column? 2 row by 2 column. I have a 2 by 2 matrix, a 2 by 2 matrix. I'm allowed to add them. They have to be the exact rows and columns. Maybe I'll actually write that below here. How we write it too is a 2 by 2. This is a 2 by 2. Now obviously it forms a 2 by 2. All right. Now let's do the next one. And actually before we start, let's do the same thing here. What's my rows by columns? I have 1, 2, 3 rows by 2 columns. This is a 3 by 2 matrix. What's this one? 3 by 2. They are the same dimensions, so what they will form is a 3 by 2. All right, so let's try this one out. 4 minus 2 is 2. It doesn't matter what order, like I'm going to go across this way. And subtracting actually doesn't matter which order you're going. 6 minus 3 is 3. Negative 2 minus the negative 4, be careful. Negative 2 plus 4, which is 2. 2 minus 2 is 0. 1 minus negative 3 is 4. 5 minus 1 is 4. So here's my new matrix. So once again, to make it possible, they have to have the same dimensions, rows versus columns. These did, they all look the same. All right, so the next part of the lesson, we look at multiplication, and it's not actually like multiplying two matrices together. It's something called scalar multiplication. So you want to copy this down in your notes here. It says multiply the scalar, which is a real number, by each element in the matrix. So let's look at 2a. Do you see how there's a 4 out front? That's a real number or a scalar. The negative 3 is a real number or scalar. So example 2 says perform the indicated operation if possible. All right, so you see there's a 4 out front. We're going to take that little 4 and multiply 1, 2, 3, 4, 5, 6, all 6 terms by it. So let's begin. 4 times 3 is 12. 4 times negative 2 is negative 8. 4 times 0 is 0. 4 times 3 is 12. 4 times 1 is 4. 4 times 6 is 24. Here is my answer. There's my new matrix using scalar multiplication. All right. Now let's look at letter B for example 2. We have to be careful with this one because you see, okay, there's negative 3 out here. I have multiplication, scalar multiplication, but I also have addition, right? What operation do you want to do first? Hopefully you realize we have to multiply first. Order of operations, just like with regular numbers, also now with matrices, you always have to multiply before you add or subtract. So let's take a minute here. So I'm going to multiply this one little piece by negative 3. Negative 3 times negative 1 is 3. Negative 3 times 5 is negative 15. Negative 3 times 4 is negative 12. Let's give myself some space here. And then negative 3 times 0 is just 0. So here's the first part. I'm just simply multiplying negative 3 by this first matrix. Now don't forget, we actually have to bring over the other matrix. So now I can add, I have what, a 2 by 2 and a 2 by 2. So 2 by 2, 2 by 2 will give me now new 2 by 2 matrix. So now let's add, combine everything. 3 plus the negative 2 is 1. Negative 15 plus 1 is negative 14. Negative 12 plus 5 is negative 7. And then 0 plus negative 3 is negative 3. And after all that work, this is my final answer for my matrix. I'm actually going to box this one. So that's our final answer. So here's a combination of multiplying and adding them together. We get a new matrix. Now the last slide deals with a little bit of a concept summary. I'm going to read this out to you. You have this in your notes. But properties of matrix operations, they work just like properties of regular numbers. So it says let A, B, and C be matrices with the same dimensions and let K be a scalar. So A, B, and C are some kind of matrix. They don't give it to you, they just give you the letters, but it's going to be a matrix. So associative property of addition works. Parentheses A plus B plus C equals A plus B plus C in parentheses. Commutative property of addition stands true as well. If you go A plus B, it equals the same as B plus A. Distributive property of addition, you take K, which is a scalar, and distribute it. So you get KA plus KB. And then distributive property of subtraction also works. When you distribute the k, you get Ka minus Kb. So all of these properties we dealt with numbers. We're now also saying that matrices allow it as well. All right, so for the last example here, solve a matrix equation for x and y. Let's first take a look. I'm going to change the matrix into an actual equation. So let's circle where the x is. 2x is here, right? Top left. All right, well, what I want you to do is go about circling the top left of everything. I'm actually going to come up with an equation from that. So do you see there's a 2 with a parentheses out there? Right, 2x plus -1 equals 10. So I'm taking it from matrix form, and now I'm forming it into an equation. Do you see how I circle the top left of everything? And I just rewrote it accordingly. We're going to solve here. I distribute the 2, get 4x minus 2. Right, because I distributed the 2. Plus and minus makes a negative, right? Equals 10. Add 2 to both sides, you get 4x equals 12. When I divide, x equals 3. And that's my first answer. So do you see how I'm going from a matrix into an equation? All right. Now I want to find y. Where's y? Y is the bottom right. So underline all of the bottom right ones. And let's write our equation out for y. 2, open parenthesis, negative y plus 5 equals 14. Distribute the 2, negative 2y plus 10 equals 14. Negative 2y equals 14 minus 10 is 4. Y divided by negative 2y equals negative 2. And that's my final answer. So we get x equals 3, y equals negative 2. All right, that's it for today's lesson. For the homework, go into the problem of the day and then complete the following 4 problems on assignment 1 in your new packet.